Then we are very different with the radius on the road. This process will be able to create the required radius on the road surface. Similar to this, all of element using a hydraulic pump, we are using the capacity mixed with different radius. Now one is hydraulic blocks, which are very difficult to machine the radial hole and the force. Using this process, we are able to push this rubber-like media mixed with the big to generate the what we will call a level link. Also, on in a place which are having the direct hole, which are machined with the required. Now we'll see the close-up view having the radial holes and tube. Now we are machining the VSSC machine to the nano level. Maybe it will achieve 2 to 3 nanometer on the. Okay, what we are doing, we are recirculating this media again and again. Now we'll see another area, actuator area. We are very powerful in developing the actuators for the various application. This is what you are seeing is a electro-hydrostatic actuator for the space application, which has an inbuilt power pack. Here, as we know, the power pack is continuously running to supply the energy to the all actuators. For example, if you see the landing gear application, only when the flight is coming down and after taking up, they will take it out, this landing gear inside. Even then, the power pack is working continuously. But this attempt is made to study the effect of the inbuilt power pack on the actuator dynamics. Now, another one what we are seeing is again it is a PZT actuated pumps, micro pumps are there, which are used to suck the fluid and send the fluid sequentially as well as a parallel to study the flow through the micro channel. What we are seeing is a quartz glass plate. We are seeing in the left side, which is used to study the fluid mixing and a division of flow. You'll see here very, very small. This is machined through our ECVM process and to study the flow through the micro channels. Another one, what we are seeing is a parallel. These are all joints. Joints we are seeing used for the underwater robotics. These are parallel platform. The top platform and the bottom platform. Bottom platform is the to move on the seabed. The audience is created. The ground is 3,000, 3,500, 4,000. Audience studying the dynamics of on moving as well as static. This platform is to liberate the medical robot. What we are doing, medical robots, calibrate flow laser. Recently, our flow laser platform is not working. See, use liberate PS4 medical robot. Thank you for visiting our laboratory, virtual visit to laboratory. Now I will take you to my talk. Okay. Munshi, I'm connected. Am I correct? Munshi?
Yes, sir. Yes, sir.
I'm connected. Okay. Can you please read what slide you are seeing?
Sensors, actuators, and effectors.
This is the work assigned to me now, correct?
Yes, sir. Yes, sir.
Virtually our laboratory. I will take you to the known to unknown. The robot.
Sir, can I record the session, sir?
No. After some time, I will tell you wherever required.
Okay, sir. Okay, sir.
Because this is already delivered by other speakers, just I will know from the participants what they know and where we are moving. And I know all, Karl Kapek, in his novel Ruhr, he developed the what we will call Ruhr robots. He coined the robot in 1921 in his play, and still people are using this robot because it is entrenched in the deep-rooted in the all people's mind. Robot will not replace any other word like a particle transfer, manipulator, or many. People are trying to rename this robot, but robotic word as developed, conceived in 1921, still people are using robots. Correct? I'll quickly recap, friends. This is required for me. The objective of this FTP is, moving towards the smart manufacturing. Already you know that industrial revolution changed our social, economic, and technological status of the country since from the 18th century, as we can call it as a industry 1.0 till date a industry 4.0, what we will call a smart manufacturing or a digital manufacturing. There is a large number of changes taking place in the factory layout. If you'll see the 18th century, all the components are a mechanical production equipment powered by the steam. All are powered through the steam. And the next level, Industry 2.0, the mass production assemblies requiring labor and electricity. The electrical energy is coming into the picture along with the telecommunication line in the second generation, 19th century, in which you are able to connect one machine to another machine, each other. Then at the later stage, Industry 3.0, what we will call the third generation, 20th century, the many powers are available. Nuclear power is available, electric power is available, steam power is available, water power is available, whatever call a fluid power. Nuclear energy is available. So many computers are there, softwares are there, and integration is very, very easy because many automated devices are there, like your CNC machines are there, flexible manufacturing systems are there, computer integrated manufacturings are possible, along with the robots introduced in the market to do the multiple tasks like a pick and place to the inspection. Many variety of work can be done through the robots, in which we are able to connect one each other and controlled in the centralized computer inside the factory. Later, what happens in Industry 4.0, what you can call it as a intelligent production system, incorporating the IoT, cloud technology, big data, which what we can call on the 2015 onwards, Germany, US, China, along with that, which all the machine tools or whatever we will call agents. Agent means what we will call in the factory, machines, workers, management, data transfer, everything, whatever you will do, device, it is called a cyber physical systems. Cyber physical systems all are automatic and able to connect each other through the smartphone. This is due to the development in the IoT, because IoT is playing a major role. As we know, today IoT becoming everywhere because of its capability to connect the many people, automobiles, houses, cities, industries, and even countries itself through your smartphone. Correct? You may think how it was happened altogether sudden because of many reasons. Almost all devices are a cyber physical systems currently. Cyber physical system means automatic and able to connect to the internet. That is one of the beauty available in the smart manufacturing. Then availability of inexpensive sensor and powerful actuators. Easy mobility is there, and cloud facility for large amount of data storage. Increased computational power, drastically improved its speed and frequency due to the development in the VLSI technology, as we have seen when it is introduced by the chip Intel 40, 4-bit processor. It is the speed is very, very small, kilohertz, and the number of transistor on the 4-bit processor, what you can call it as 2300. Now, the number of transistor on the chip or the chip of atom size is a billions of transistors are integrated due to the development in the VLSI technology. Speed achieved is a gigahertz, as we have seen. There are easily accessible and usable data analytic tools are there. Availability of secure open platform for designing and IoT implementing solutions are available. So IoT design goal is to connect any device, anybody, anywhere, any business, any network, anytime through Internet of Things. Meaning using cloud, the data exchange is taking place from the machine. With this technology, machine can interact, human can interact, the human management can talk all through the smartphone. Because of this development, please note, friends, currently number of connected things are exceeding the number of people on the earth, as because each person now you will see we have connected through the internet 3 or more devices, such as my mobiles, correct, laptops, desktops, wearable devices, and household equipments and office equipments. At a time, I'm connecting in our house itself, based on number of people, we are connecting 3-4 devices of each. Meaning, if you see the number of devices connecting from 2015 to 2025, you will see we are able to achieve 75 billions of devices to be connected in the 2026. The expected annual economic impact is 2.7 trillion to 6.2 trillion US dollar from the Internet of Things, because it is everywhere we are using to make the system cyber physical systems. So many researchers from the academia industry are working to develop the next generation intelligent smart manufacturing system, what we will call as smart agents, to think like a humans, take a decisions like a humans, achieved through the artificial intelligence. That is what we are doing, is a mimicking the human brain in intelligent agent like a robots or a machine tools. Please note, friends, now what we are doing is we are making the machine is a intelligent, human intelligent. Human intelligent means same brain I'm mimicking in the intelligent agent, as because human can think and take decisions very quickly based on the environmental condition. Same thing, we are embedding this intelligent power in the industrial robots as well as the mobile robots. There is a tremendous growth in the manufacturing industry from the standalone machine to flexible manufacturing system. Now what we will call industry Internet of Things. The IIoT, are briefly known as Industry 4.0 or smart manufacturing. Many names are there. The ultimately what we are doing here, friends, the digital transformation journey in the manufacturing process, which is fully integrated, collaborative, that respond in real time to meet the changing demands and conditions in the supply chain network and a customer needs. So currently, industry should be a more smart, reconfigurable and flexible in order to address dynamic, global and volatile market, with more emphasis on the individual customer rather than the batch or mass production, which we have seen in the discrete manufacturing industries. Please note, friends, now we want to design the system, manufacturing system, more smart, more reconfigurable, more flexible enough to handle individual customer, because the customer is inside the network now in the smart manufacturing. Previously, Industry 3.0, you will see customer are outside. All the design and manufacturing is done inside the factory. Customer don't know, only he will get based on his requirement needs. The designer will do inside, all manufacturer will do inside in 3.0. But now Industry 4.0, customer is inside the circle. He is knowing how his product is manufacturing stage by stage. At any instant of time, he may change his design by communicating through your IoT. So your manufacturing system should address more efficiently, more effectively the individual customer rather than that. Meaning currently all industries are trying to move towards this smart manufacturing, even though their product and processes are different. You will see standardizations are different. Technology are different. As an example, you will see technology in automotive industries like a Hyundai, Maruti, Nissan, Volkswagen, Ferrari, all are automotive industry, but their design concepts are different to meet different customer taste. Similarly, if you see the process industries like chemicals, milk, oil refineries, what you can call it is a continuous flow. Please note their design, manufacturing, testing and research, etc. all are different, but even then all are interested to move towards this Industry 4.0 to gain the many advantages of this in future. If you see this Industry 4.0 works mainly on the hardware and software integration in reality, along with the powerful technologies like IoT, artificial intelligence, data science, robotics, cybersecurity, 3D printing technology to achieve high speed, high quality, more flexible products by utilizing the existing available resources with zero downtime, which is a very important aspect or a essence of the global market now to meet the variety of customers. if you see some of the key features found in the IoT, all are cyber physical system or ASMOs, where in each case use IoT, big data analytics, cloud computing. So what we will call it as a previously man-machine system, now man-machine IoT system. Now customer are the part of the industry 4.0. Some key features they will see. You will see in the automated factory, automated machine tool, automated material handling, loading and unloading with robots, assembly robots, quality stations, automated storage, cloud computing, storage of huge data, and effective interaction is taking place, human to human interaction, human to machine interaction, factory to factory interaction, factory to external world, all through your Internet of Things. Where data exchange is taking place in the cloud, because the large amount of data you can store it every instant of time based on the requirement. For example, people require different data. Management want to see their sales and profits, correct? Based on their requirement, these all data are disseminated and giving to the customers as well as the people working in the industry. So this transformation is a dynamic response. Smartness and compactness of the factory are due to the large development in the VLSI technology, that is the availability of the powerful processors. As we know that the number of transistors or a chip increases from thousands to billions. Similarly, CPU speed is increased from kilohertz to megahertz, gigahertz, and now people are giving you terahertz speed also, correct? Now, today's talk is just a glimpse on. Now, if you want, we'll take part. Okay. Sometime we'll record. Vamshi.
Okay, sir. Okay, sir.
Sometime. Okay. Sometime you may record it. Okay.
Okay, sir. Okay, sir.
The today's talk, what I'm talking, just a glimpse on robot. You already know it, robot. What is a robot? You know already, correct? Many 2-3 lecture hours are over. Robot application, enormous amount of applications of robots are there. Robot anatomy is very important to integrate our sensors and actuators. If sensors and actuators work effectively, then only we are achieving the required task by the robots. Okay, there is a close integration between sensors and actuator through your controller is a very essential requirement, prerequisite in any automated system. That's why robot is called as a mechatronic system. Mechatronic system is what? The integration of sensors and actuator in the precision mechanical system. Mechanical system means, in our case, the robot consists of so many things. What are these? As I am telling you, the links are there, what I will call the rigid bodies. The various joints are there, which will connect the links, one link to another link. Based on the required motion, the different joints are there to provide the relative motion between the links. And body is there, complete body. And arm, what you will call your human arm. And the wrist is there, where you have to attach the end effector, a tool or a gripper. This is an anatomy. I'll show you anatomy neatly in the different slide. Different types of robot sensors are available. Different types of actuators are available. Based on your requirement, based on your application, based on your precision, you have to choose different sensors and actuators for your applications. And different types of end effectors. Please note, friends, every day, every hour, different types of sensors and actuators are coming into the market to meet the customers, because customer demands are huge. Whatever sensors available, 1 week back, now different sensors are coming into the market to suit the requirement. Think some of the sensors, what I'm telling is, as you already know it, are the vacuum is there, you have to search. So many sensors, actuators are available. As we have seen this industrial robot, why I'm talking industrial robot, mechanical engineer will talk the robots used in the manipulator, what we will call a mechanical manipulator. Because robot is a very wide term. But a robot is an automated device. Automated device in robot, it is a fixed platforms. The movable platforms are also there, robotic vehicles, what we call. Whether it is a autonomous or the wired or wireless, many things are there, you know it. Now, the whole talk is focusing on industrial robots, as because it is a fixed platforms, knowing the known number of joints and links. which will give you the different degrees of freedom of the robots. As you know, the Rajalakshmi previous speaker told you about the degrees of freedom, which is a prerequisite to design of any robots, which will give you the work volume what you require, correct? Where you want to work in the space. An industrial robot, as we know, it is a general purpose, programmable and reprogrammable machine manipulator possessing a certain anthropomorphic characteristics. Why I am telling certain anthropomorphic characteristics? The robot, what you are seeing in the cinema movies, correct, are serial. They're exaggerated the robot by attaching the many anthropomorphic characteristics on the robot, but all are not robots. To overcome this confusion in the minds of the people, the industrial robot is a general purpose, programmable and reprogrammable machine or a manipulator possessing certain anthropomorphic characteristics or a humanoid characteristics like your arm. Only you will think this arm maybe used to do multiple tasks, or it works in the space. I will tell you how arm will work. But body is fixed to the ground in the industrial robots. To the effect and effector, you have to attach the various tools and grippers to do the various work. You program it for pick and place, program it for assembly, program it for the painting, various applications. So the arm and programmability ideally suited for many or variety of production tasks. If you see in industry itself, the robot is used for material handling application, a pick and place, correct, or in assembly, or it is an inspection, many material handling application it is, or material transfer, what we will call indirect application. Indirect in the sense that the robots are used to pick and place the robots, palletizing and depalletizing. They will work indirect in the sense that they are not working with the machine tools. They will work to assemble all the finished product in the container through the conveyor system where the parts are moving, or arranging the raw work parts on the conveyor system. They'll work indirectly, indirect application. If you see second application, material handling, machine loading and unloading application, direct application. The single robot, you will see the work cell. Work cell means how one robot is serving the various machines. If you see machine loading and unloading application, the one robot, work cell means one robot serving 2-3 machines at a time. Either it may be a loading, sometimes loading and unloading, sometimes only unloading, sometimes loading, various applications. Robots are working with the machine tools. The part handling application, for example, assembly and inspection, these applications are categorized like this. Then processing operations, this will include the spot welding operations, correct? Continuous arc welding applications, spray coating application, other processing operations like drilling, grinding, polishing. These applications are very minimal used by the robots. I will tell you what is the reason behind it. Okay. Then all these tasks, material handling or a processing application, you have to perform with high endurance, high precision, high speed. This is only possible with robots. If you see this before designing or before using the robots, you have to see the general consideration of robot application. You may ask, industry all work what now performing will use the robot? Not at all. The robot will call some of the challenging tasks, which humans are not able to do it. In some cases, for example, if you see the hazardous condition or uncomfortable working environment, where a potential dangers on health hazards for the worker due to heat, radiation, toxicity, or where workplace is uncomfortable or unpleasant. For example, breadboard manufacturing, okay, circuit soldering. These are very dangerous to the human health. Example, hot forging, die casting, spray coating, foundry operation, electronic circuits are repetitive tasks. Sequence of elements do not vary from cycle to cycle. It is possible that could be programmed to perform the task. Repetitive tasks, humans are not suitable. For example, pick and place continuously not possible by the humans. Machine loading and unloading, continuously difficult. Inspection of the component, continuously very difficult for the humans. Assembly also same. Wherever large number of assembly, where large number of inspection of components are required, robots are best suited. Similarly, difficult handling, the work parts are awkward or there, hot, heavy metals you have to handle, delicate parts like a silicon wafers. That time, robots are best suited. Correct. Example, men's part, sheet metals, delicate parts are there like bulbs, wafers, milk packets, cakes, hot castings, hot forging, powders used for detonate. See now, there are robots are used for various applications. This will call you for the different types of end effector and different types of sensors. The sensor used in the pick and place is entirely different from the sensors and actuator used for the other applications. These applications are very, very important to select the proper sensors and actuator. Also, you will see multi-shift operation. If the initial investment of the robot can be spread over 2 to 3 shifts, the labor saving will result in a quicker payback. Such, for example, plastic molding parts, die casting, welding, painting, assembly, inspection, you use the robot multi-shift operation. The robots, when you are selecting, designing, you have to consider these 4 important aspects. Also, you'll remember selecting the robot for right application is very important. Don't think all robot installation have been successful. Some historical data shows that misapplication, poor selected equipment, non-acceptable by the factory personnel are there. So what to do, friends? Ideal application should be one which should be possessed with the 4 general characteristics like a hazardous environment, repetitive task, difficult handling the work parts, multi-shift operation, along with economic analysis is must to see the cost reduction and protective improvement in the longer range. Some of the notable application of the industrial robots, if you see, you already seen this. Okay, now please focus on the grippers and joints and links, how they will work, because robots use it for pick and place, how many degree of freedom, robots 6 degree, 4 degree, 6, what are these degrees of freedom? You'll see now the pick and place applications from heavy to delicate parts having different degree of freedom. Palletizing, very important, which is a 1 more degree of freedom because it should pick the parts on the conveyor one by one and place it accordingly programmed in the boxes. Once box is full, then box will move, empty box will come, again it will loading, palletizing. Similarly, depalletizing, the ready-made work pieces are coming, then it will open it and arrange it properly, depalletizing for the machining or whatever the operation it is. Again, higher degree of freedom is required to orient and hold the workpiece in the different directions. The machine loading and unloading, as I have told you, one central robot serving 2-3 machines in the work cell. Some of the major class of applications where human hazards are there, die casting, plastic molding, forging, stamping operations, many more. Similarly, if you see the processing operation itself, apart from the material handling is the topest where materials are handled by the robots for various applications. Second class of application, if you'll see the processing application in which the spot welding is best suited for the robots, wherein the dozens of robots are arranged on the 2 sides of the work parts where car bodies are moving. They will programmed in such a way that they will do their spot welding. They will move up and move up. They will do. There is a close synchronization is there between the moving body and this robotic end effectors. This is side I am showing you the different types of welding guns. Please, C type, scissor type, X type. There are so many end effectors are there attached to your robotic wrist. Seam welding, you will see again a high level of algorithm. In seam welding, what it is, I want to move our robot and place it your seam continuous welding, which requires the precision cameras to monitor the proper deposition of the weldment. Again, here it is a dozens of robots on either side of the robot. Similarly, you'll see spray painting operation. Some of the popular application, very drilling, milling, polishing, all type operations, because you will see in all the cases what it is, only tool or end effectors are changing. Please note here. your gripper for handling the workpieces, or when you are handling the cutting tools, cutters or brushes, this is called a tool, meaning different types of end effectors are there based on the application where you are attaching to the robotic arm. Assembly robots, you will see again, it is a grippers. You will see different types of grippers are there to handle the different types of work parts, upwards, different sizes. Inspection robots are there. In spite of that, the robots are used for various applications in industry. The handling is a major. You'll see now the statistics of IFR, the World Robotics 2024, there. This statistics is continuing from the 2021, 22, 23. Previously also, the industrial robots are mostly used for pick and place, or the next one is a welding, seam welding, spot welding, then assembly, clean room, dispensing. This is continuing. But if you see the statistics, every year the handling application is occupying the major role everywhere. If you see this industrial robots application throughout the industry, different category of industry, automotive is number one, then electrical or electronic industry, metal machineries, and plastic and chemical products, food, and all other are coming in the next category of robotic annual installation. If you see the region wise, Asia, about 70% of the robots are installed in 2023. Still, this growth is continuing compared to Europe, America, and other countries. Similarly, if you'll see the annual installation in the 1,000 cities, what I'm showing you now, every year the installation of the robots increasing. If you see the worldwide, the robots installed and used in the factories are China is a number one, correct? 154,000 of industrial robots are used again, it is the 2018 and 19 report it is. Next slide, you will show the large amount of Chinese are using this industrial robot for various applications. Next comes the Japanese, United States, Republic of Korea, Germany. If you see, India is in the 11th place in 2019, but it is overcome in the 23 and 24 IFR report. If you see the annual installation of the robot is, India has moved to the 7th place, meaning we are also not very inferior. Previously within the 10th place, now we are moved to 7th place where robots are used large. But leading is China, 38%, followed by the Japan, Republic of Korea, US, and Germany. If you see the India itself, the drastically increasing trends, 2013 only 1,917. Now we are 2023 robot installation all over India is 8,510 robots specifically for the automotive industries. The global estimated supply of robots, you will see 2027, 602 thousands of units are required in the 2027. Again, it is an IFR report, meaning every time the installation or requirement of the robots is depending upon the growth of our country. But top 5 global robotics trend, you will see now people are embedding the artificial intelligence and machine learning, cobots for the new applications, mobile manipulators are there, similar to movable platform, what I am telling, digital twins and humanoid robots are embedding in this. Now I am showing you friends now to sensors and actuators for your thing. If you see, this is a robotic layout. What robotic layout consists of? You'll see now what are the things are there. Robotic layout consists of a manipulator. You will see the whole is a manipulator. Please note here, manipulator composed of what I will call anatomy. Various links are there connected through the joints. The joints are driven through the various actuators. The manipulator means up to this red color is there. It is a manipulator, robotic arm, which is having the base, shoulder, your arm, forearm, arm, whatever it is. To this, I am attaching the second one is the end effector. This end effector to do the particular job. The design of end effector based on the application. For example, pick and place application with the 2-finger joint is entirely different from the 5-fingered grippers. 3-fingered gripper, 4-fingered gripper, or you have to attach the different tools like a polishing tools, cutters you have to attach, many things, correct? Or vacuum grippers you have to attach to the end effector through the faceplate. Please remember, end effector is the second part. Manipulator is, what is that? Manipulator, body with arm. Please remember, body with your arm, what you are saying. To the end of the arm, you have to attach your end effectors. Okay. Now you will see actuators. Actuators are what? Drives. Actuator will convert the any input energy into the mechanical motion, either a rotary or a translatory. Rotary, we are using the rotary joints. Various types of joints are there, I will tell you. Linear, we are achieving. Simple is a piston and cylinders. Drive through the hydraulics or in pneumatics. Or some of the electric drives are also possible to achieve rotary as well as linear motions. Then sensors are there. Sensors are very important. Proprioceptive sensor or extra perceptive sensor. Proprioceptive sensors are used to, some of the sensors are to know the internal status of the robots to correct by itself, or exteroceptive sensors to capture the environmental information. Many informations are their environment, because your end effector should react to the external environment. This is done through the sensor information processed in the controller. Next, you will see after sensors are what capturing the information, internal status as well as the external environment. Then controller, from the sensor information is coming to the controller to process it, and the correction is done through the what I will call actuators. Then computer or teach pendant is there, or even a smartphone, where a communication interface it is for monitoring and operating the robot. Please note, friends, robotic layout means the robot, end effector, correct, actuators are there, sensors are there, and controller is there, robotic controller is there. All three achieved through your computer or a smartphone or a teach pendant you have to control. The whole together, it is called as a robotic layout. This layout is varies from applications. If you see the manipulator means what it consists: body, arm, and a wrist. Please remember, or end effector, what we will call. Most of the robots are mounted on a base which is fastened to the ground to ensure the rigidity. That is what we will call a link zero. Vamshi Krishna.
Sir, tell me, sir.
Yeah, you are there. Correct.
Vamsi Krishna.
Yeah, Vamshi Krishna. Someone is there. Okay, good, very good for responding. The madam is covered many of this, robot anatomy, how to number the links, joints, correct? All degrees of freedom.
Yes.
Fundamentals, everything
She covered, no? Okay, if even the little bit is overlapping, please bear with me. Okay, some of the prerequisites are.
Okay, please, sir.
Okay,
Please, sir.
please. Okay, thank you very much.
Thank you, sir. Thank you, sir. Please, sir.
Okay. Then the base is very important, where your shoulder, arm you have to attach, which is a rigid body. Link zero it is. The wrist is their end effector, mounted to the end of arm through the face plate and some hardwares like a nut and bolts, whatever it is. Okay, this is used to orient the object. The relative motion between, please note this, the relative motion between the body, arm, and wrist achieved through the series of joints to accomplish the desired task. Desired task may be a linear motion or a rotary motion, or sometimes linear and rotary to do its intended task. For example, you will see, friends, one I am showing you a serial manipulator. Serial manipulator means, what is serial manipulator? One link, whatever base, what I am telling, it is fixed to the ground. Other is, open. This is open kinematics, open chain it is, open chain, not a closed chain. What our industrial robots are generally the open type it is. You will see now, link zero is a rigid, all our links are rigid bodies, okay? Any shape doesn't matter in our case, okay? The link 0 and link 1 is connected with joint 1. Then link 1 and link 2 is connected with joint 2. then it is an end effector. Correct? When we are formulating you will see now, this is arm and body motions. Correct? Arm and body motion, how many degree of freedom? 3 degree of freedoms are there, arm and body. Then end effector is having the 3 degree of freedoms. Correct, friends? As we know, the same thing I am mentioning here. Arm and end effectors are playing a major role. If you see the numbering of the links and joint, which is a prerequisite in the DH parameter, always the links are numbered starting from the immovable base, which might be generally the link 0. Then the first moving body is link 1, and so on out of the free end of the arm. Always you have to mark link 1, link 2, link 3, link 4, move towards the end effector always. You refer to here in your figure, when I am showing you 6 degrees of freedom robot, the link 0 is a base, immovable base, correct? Then the link 1 and link 0 is connected with the rotary joint, what I am showing you here. The joint 2 is connecting between you'll see now, the joint 2, here you'll see joint 2, you're seeing my cursor, joint 2, connecting between the link 1 and the link 2. Similarly, if you'll see the joint 3, again it is a rotary, joint 3 here, connecting between the link 2 and the link 3. Correct? Joint 4, again you will see, connecting between the link 3 and link 4, and so on. It is moving towards the end effector. Please note here, correct? The starting link 1, link 2, link 3 all starts from the base. Similarly, the what we will call node number N1, N2, N3, whatever we will call, or J1, J2, J3 will call joint, starting with the base, move towards the end effector. Please note, in order to position the end effector in space, how many degree of freedoms are required, friends? 6 joints are required to place anywhere, meaning 6 parameters are required, 3 for positioning and 3 for orientation. Now, how we will understand this? Arm and body motions are used to position the end effector in X, Y, Z. Please see my hand, X motion, Y motion, Z motion, what we will call the major axis. Major axis, it is a X, Y, Z motion, arm and body. Similarly, wrist is there, at the end, the wrist is having the rotary motion in X, rotary motion along Y, rotary motion along Z. In a pitch or roll, meaning arm and body is having the 3 degree of freedom. What is this? X, Y, Z, major axis. The minor axis means the wrist is having the orientation matrix. Orientation along X, orientation along Y, orientation along Z. This can be explained very neatly in the arm and body motion. Now we'll see now, I marked here with the green color, arm and body. What is this? The first one is a vertical traverse. The whole body is moved up and down. Correct? Vertical traverse. Radial traverse means you take the wrist in and out. Correct? Then rotational motion means the whole body is rotating along the vertical axis. These are arm and body motions. What is vertical traverse? Up and down motion of the arm. Radial traverse, extension and retraction of the arm. Rotational traverse means rotation of the arm about the vertical axis. In our case, what I am seeing here. Similarly, you will see only wrist end effector, wrist assembly, you will see, it is having the wrist swivel, rotation of the wrist. You have to rotate. Similarly, wrist bend, moving up and down. You see all up and down motion, wrist bend. Next, wrist yaw, meaning left and right motion. Meaning, wrist assembly is having 3 degree of freedom, minor axis, and arm and body is having the major axis. Meaning, if you'll see this representation of the frame of an end effector is, generally you will see the F is a frame, it is having, what is that matrix? It is a, what you are seeing now, 4x4 matrix is used to represent the end effector position in the space. You will see end frame. Frame F is a end of effector frame, it is end. How it is? You'll see it is having Nx, Ny, and Z, normal vector, orthogonal vector to this, Ox, Oy, Oz. Approach vector is Ax, Ay, Az. This is what we will call 3x3 matrix is there, no? Nx, Ny, Nz, Ox, Oy, Oz, AX, AY, AZ, these are called as a cos and sin theta values. Only you will fill it here cos and sin theta values if you are rotating along the x-axis or y-axis or a z-axis. Only what it will come, cos theta and sin theta will vary here. Then you will see the dx, dy, dz are the major axis, meaning the positional vector is this, dx, dy, dz. NOA is a, what it is? It is a orientation vector. Please know, this 4x4 matrix is a homogeneous transformation matrix, which is a square matrix used to calculate the inverse and multiplication of the matrix, because both cases, order of the matrix is the same. You know already this. If you see this rotation along X, Y, Z of the robots, this is the identity matrix I am showing you for you, identity matrix, in which top one, as I have told you, 3x3 is a orientation matrix composed of only what it is, cos theta and sin theta. How to remember this? If I am, then last matrix is there, no, that is a position matrix. Positional matrix is used to X, Y, Z motion of the, to place the end effector in space. After placing orientation along the X, orientation along the Y, orientation along the Z is achieved through the your wrist. Please note. Then you will see now I am writing here rotational matrix along X, Y, Z. It is very easy to remember. When I am writing the rotation along the, now I am filling the 3x3 matrix only. Please note here, I am filling the 3x3 matrix of cos and sin. Now when I am filling the x-axis, you draw one line here. You draw one line. Don't fill anything here in one line. But next thing, when I am filling the y, you will draw second line. Don't fill anything. And z, draw line like this. Don't fill anything. Only which how to write cos theta. All diagonal elements are there. No? You see now all diagonal elements are cos thetas. Okay. Then half the diagonal sin thetas are there. How to write this half the diagonal? Minus 1 raised to k. Please speaking, can you please mute
Sir,
your
1 minute, sir. Sir, 1 minute, sir.
Sir, 1 minute, sir. Will
Sir,
1 minute, sir.
1 minute, sir. Sir, here one participant Manoj, please turn off your mic, sir. Manoj, participant, kindly turn off your mic.
Hello, Vamsi sir, can you speak?
Sir, thank you, sir. Sir, please, sir.
Sir, audio is lacking, sir.
Somshekar sir. Somshekar sir. Sir.
Sir, voice is not coming, sir. Somsekhar, sir.
Sir, your voice is not audible, sir.
Sir, please check your mic, sir.
Vamsi sir.
Sir.
Unmute it.
Hello,
Now,
sir.
now it is okay?
Yeah, sir. Now you're coming, sir, your voice.
No, I think you did there. You know, you allow me to talk. Others will switch off,
Yeah,
please.
sorry, sir.
Okay.
Maybe
Okay, I think-
one more sir. Please, sir. Please, sir.
Yeah, I think you have stopped my thing only. I'm thinking. Okay, no problem.
Yeah, mistakenly, instead
Yeah,
of others, it has turned out, sir.
Yeah, that's one thing.
Thank
Okay,
you,
no,
sir. Thank you, sir. Thank you, sir.
no problem. Good. Now we will see this, the kinematic pairs, what we will call the types of joint. Kinematic pairs, you know already the connection between the pair of bodies, meaning connecting between the joints and links, how it is achieved. The upper pairs are there, lower pairs are there. All we know that from the previous lecture. In the robotics, we are using the lower pair where surface contact is there. Upper pairs are very less used in the robotics, where the LiDAR point contacts are there. You'll see here the one what I am showing is 6 degrees of robots. You'll see now base and a wrist attached to the ground. 6, what we will call. Then you'll see now shoulder is there, correct? Shoulder, you'll see. Then elbow is there, your elbow, arm you will see now, shoulder, elbow, and a wrist. This is what we will call the robot. When you are finding out the degree of freedom, only you have to do up to the wrist. Don't attach any end effector. The work volume, they are arriving up to the wrist, moving in the different motion, whatever you are selecting the joints. End effector is what we will call a grippers or a tools. Now it is all our rotary joint, what I am showing you here in this case. Correct. In the line diagram, I have shown here base, which is fixed to the ground, then arm, correct. Then your elbow is there. Then at the end, wrist is there. To the wrist, you are attaching the end effector. End effector may be the grippers when you are handling the work part handling, or a assembly, inspection, whatever it is, or you are used the tools like a welding gun or a spray painting or a cutters. The end effectors are different, okay, which are used to manipulate the environment. You will see, friends, very important thing is all degrees of freedom. As I have told you, links are rigid. They will not do anything. Links are to form the work volume and all. They will take the major role also. The size and shapes we are not taken in the work volume or anywhere because it is a rigid body connecting. The joints are very important. Joints will connect one link to another link. Correct. This is characterized by the one what I am showing. Link 1 and link 2 connected with the revolute joint. Rotary joints, what we will call either electric motor, hydraulic motor, pneumatic motor, which will be revolve in one direction. It is 1 degree of freedom. You will see prismatic joint, which is the translation along x-axis or a y-axis or whatever z-axis. Again, it is a 1 degree of freedom translation. I'm showing you piston and cylinder or a simple mechanical motion with respect to the one to another. Okay, prismatic joint, P, 1 degree of freedom it is. Degree of freedoms are very important, friends, when you are determining the degree of freedom of the kinematic joint. Very, very important it is. Your number of degree of freedom increases, rotary joints increases, complexity of the kinematics increases, as you know from Raja Lakshmi's talk. Cylindrical robot, you will see 2 degree of freedom, cylindrical joint, what it is? It is rotation as well as moving up and down. Similarly, helical, you will see it is a 1 degree of freedom, what we will call coupled rotation and translation at a time. Planar joint, you will see 3 degree of freedom, translation in X direction, Y direction, as well as it will rotate along the plane. Spherical joint, 3 degree of freedom, all rotation in X, rotation along Y, rotation along Z. If you see you are seeing the degree of freedom for the
Sir?
different.
Sorry to disturb you, sir. So
Not you.
participants are from the participants end and other end. So, sir, can we close the session by next 15 minutes, sir?
Oh,
Sorry, it's at time 9 o'clock. So
okay.
many were requested.
Yeah, another 15 minutes, I'll finish.
Yeah.
Okay, no need to worry.
Yeah, please. We have 10 to 15 minutes, please, sir.
Yeah, I'll finish
Okay.
within 15 minutes. Okay.
Thank you, sir. Thank you very much,
Yeah,
sir, for
no
understanding.
Okay. The linear joints are there to achieve orthogonal joints. The different types of joints are used in the robotics to achieve the required kinematics, correct? Uh, Most frequently, revolute joint and prismatic joints are used in the robotics, okay? If you see the combination of these joints, which will result in the Cartesian coordinate system, cylindrical robot, spherical, SCARA and articulated robots. If you see the physical configuration, whatever and what volume, where the robots will work, depends upon your selection of the joints. If you will use, you will see now, whatever the grippers and tools are not attached to arrive the work volume of the robots. In the Cartesian coordinate robot, you will get the box type work volume. Cylindrical robot, the work volume is shown. The work volume determination is very important, which is based on the number of joints. And if you see this now, the transducers and sensor, both are the devices that convert one type of physical quantity to another form without sacrificing the laws of conservation of energy. Transducer sensors are, simultaneously they are using. Transducer is a physical and essential element of the sensor. On the other hand, a sensor is a sophisticated sensor in the sense that it contains the signal conditioning circuit or amplifying circuit, meaning where the weak or raw signal given by the transducer is converted into the higher signal which drive the element. You see now, very simple. The transducer is a part in the sensor, but sensor is a sophisticated one, which consists the signal conditioning circuits. The inputs, whatever you are giving, either the pressure, temperature, force, whatever it is going to the transducer. Transducer convert this into the equivalence, which is a very weak signal, which is input to signal conditioning circuit. Signal conditioning will amplify this to drive the sensor output. This is the whole, meaning sensor consists of transducer and signal conditioning. Okay, important features, if you see sensor system, a generalized system consists of basic functional element, integral parts of all the instrument. Their transducer elements are there, and signal conditioning elements are there, and data presentation elements are there. Some, quantitatively we have to express, that is, these are called a basic elements in the sensor. Auxiliary elements are there based on the type of requirement, nature of measurement technique. Some of them are calibration elements, external power element, and feedback elements are there based on the physical quantity to be measured. If you see the block diagram, basic and auxiliary element, this is showing you the physical quantity to be measured. There are various parameters which will go to the primary sensing and the secondary sensing based on the requirement transducer, which will be given to signal conditioning element. Then it will drive the output element, what we will call data presentation element. This all together, what we will call a sensor. Then you will see the desirable characteristics of the sensor or actuator. It should be borne in mind while selecting this, should recognize and sense the desired input, correct? Should not alter any event, should be amicable to modify using the appropriate processing and displaying device, should have a good accuracy, should have a good reproducibility, should have amplitude linearity, should have an adequate frequency response, should not induce any phase distortion, should withstand hostile environment. The robotic sensors and actuator, they will the backbone and the core components that allow a robot to perceive and interact with the environment for successful automation. Sensors are used to detect changes in the environment, such as motion, temperature, or light. They transmit this data to the robot controller. Robot controller will process this sensor information. Then in turn, it will issue the signal to the actuator to do its work. And then there is a feedback between all this. This sensor, controller, and actuator integration is crucial for robots' autonomy, adaptability, and ability to perform in the environment. Sensors are most often used in combination with a complex algorithm to enable a robot to perceive the environment. There are various types are there. Cameras, for example, to capture the images and detect the motion, to navigate its environment. Laser range finders are there. Inertial measurement units are there. By combining the different sensor, robots can interpret their environment much like the human world. The popular sensors, what we will call it as a tactile sensors are there, providing the touch, pressure and force. Our proximity sensors are there to measure the distance to objects. They works on the infrared or ultrasonic based. Encoders are there to measure the position or velocity of the joints for the corrections, to place the objects in space. Inertial sensors are there, accelerometer and gyrometer to measure the motion and orientation of the joints. Vision sensor are very essential to detect the size, shape of the objects in the environment, recognize it. Some of the popular actuators, if you see, the electric motors, hydraulic and pneumatic systems are there. Artificial muscles, they generally works with the PJT actuator, SMA actuator, and many other newer technologies to drive the artificial muscles. And smart actuator, meaning it is an integrated sensor, work with the environment. The use of sensor actuator in robot range in-home tasks such as opening and closing the door to complex and precise motion like a material handling, welding, assembly, inspection, fabrication. Medical application projects are still complicated where they are working with the humans operator. Similarly, actuator in medical field can also vary some prosthetic limbs to higher level. Sensors are getting both, faster and cheaper. Integration is very useful, and actuators are getting faster and more powerful. Dynamic response, precision, higher speed, and accuracy is more. This is one what I'm showing you, the smart actuator. It is integrated sensor, which will be sensing light, heat, and humidity, used for the various applications like a nuclear reactor, the home automation and security, and soft robots, which is having the multiple actuators that respond based on the sensor input in the environment. You will see the end effector very quickly. What we will call an end effector is a device attached to the robotic arm that performs the specific task, acting robotic hand or a tool. Now, what we are seeing is a claw, which is drive through the motors, okay, electric motors, that is a BLDC motor, or a pneumatic drive using compressed air to open and close the grippers. Again, it is a claw. And hydraulic cylinders are used to move the claws. Correct. The robotic grippers allows to interact with the environment and are tailor-made to suit the wide applications, including the gripping, welding, painting, assembly, and inspection. Example of mechanical grippers are a vacuum gripper. Vacuum grippers generally uses the foam pads. Okay, you'll see the comparison of this mechanical, electrical, and hydraulic actuator based on the transmission of the power, energy transmission element, energy carriers, force density. Electrical actuators are low, force density is more in mechanical, high to relatively low in hydraulics and pneumatic. Control capabilities very good in electrical compared to the others. Correct. Safety wise, almost all are same. Efficiency wise, we will see the electrical actuators are losses are more here. Mechanical actuators are very good. Hydraulic and pneumatics are bad because of the leakage. Flexibility in construction, you will see the electrical actuators are very good, very easy to implement, and mechanical actuators are bad. Hydraulic and pneumatics is very good. Wherever the high power to weight ratio and high speed of response is required in the actuator, hydraulic and pneumatics are suited for the various applications. Please note, friends, using the electrical actuator, mechanical, hydraulic actuator, you will achieve electrical generally the rotary, and mechanical you will use a linear and a rotary actuation is possible. Hydraulic, linear and rotary actuation is possible. Comparison wise, you will see the electric motor and hydraulic motor, the sum of the parameter, you will see the moment of inertia is 50:1. Okay, weight you will see 12:1, and the moment of inertia to torque you will see 100:1. Space requirement 20:1. Meaning hydraulic and pneumatic motors or cylinders are more powerful based on your application. Pneumatic is best suited for high speed of response, moving the grippers very quickly, and high precision is possible in the hydraulic actuator. Then you will see the end effector. End effector is the last part where you are attaching to your arm, correct? Arm is having, as we told, the orientation, pitch, yaw, roll. How we are attaching? Using the faceplate and some hardware requirement. You will see now here, the vacuum pad you have to attach, or the opening and closing claws will attach, correct? You will see now, the robot, 6 degree of robots is carrying the cutter to cut the workpiece, or here you will see chain, which is available in the polishing tool in the second, or the group of robots working. One first robot is cutting the workpieces, moving over the conveyor. Second robot is making the polishing, correct? Some of the grippers you will see pivot action gripper, mechanical gripper, sliding motion grippers, or a double grippers. You will see now 2 grippers on the robotic hand, or a vacuum operated handcuffs. The different grippers are used for pick and place. Generally the claws, like different types of 3 fingers, 2 fingers, 4 finger things are there. Welding gun, where it will carry the tool, similar to the cutters what I have shown you previously. The foam pads are used for pick and place, either pelletizing and depelletizing operation, what I have shown here. Spray painting gun, again it is a tool attached to the end effector. You will see in all the cases, friends, irrespective of the application, robot is a multifunctional manipulator, programmable, reprogrammable. Whatever you will attach to the end of arm, it will do its purpose, whether it is a pick-up place, or a welding, or a spray painting, or a vision, whatever it is. You will see now different types of delta robots are there to handle the different types of work parts in the industry, or anthropomorphic characteristics like a finger, 2 finger, 3 finger, 4 finger, and 5 finger hands are there. Okay. Now, shall we stop now?
Yes, sir. Participants are putting lot of messages in group.
Yeah. I know it. So many slides are there further. Now I reach nearly 61. Still, many things are there. We'll stop it now. I will go directly to conclusion part. Okay. Then I will take another 5 minutes. Okay. The technology is now driving force beyond the evolution. As new and better things come out, we have to adapt them, not to resist, as because something change our entire life. Robotic is a hot field which continuously makes the news. The rising demand for industrial robots to augment the market growth with the development of cloud computing, big data, sophisticated processor, making these robots collaborative, working together in the industry. The growing penetration of IoT concept, investment in robotic research to form the flexible, configurable, and mimicking the human brain to suit for the smart manufacturing. Industrial robots have witnessing the huge demand over the past decade owing to the adoption in the smart factory. With the development of industrial robots, programmed robots have reached a high level of performance in real-time application, accuracy, robustness, and compatibility. The availability of small capacity and cost-effective solutions are available to handle the different robots in the different environment. Now people are thinking to develop this autonomously, which will work in the structured as well as unstructured environment like a humans. Thank you one and all for your attention. Sarve jana sukhino bhavantu. Any questions are there? I will take 1 or 2.
Thank you, sir.
Yeah.
Dear participants, I kindly request you to, if you have any questions, please feel to ask. Unmute yourself and ask the question.
Good evening, sir.
Yeah, good evening. Who is this?
This is Mahesh Kumar from Agni College of Technology, Chennai.
Very good, Mahesh. Tell me, Mahesh.
Sir, I am handling a robotics course for the 5th year. I have one doubt. What is meant by harmonic drive, sir? It is there in the syllabus. Harmonic drive.
Harmonic drive. It is based on the motion.
Yeah.
You get the harmonic motion. How to design if I want the harmonic motion in the robot for some application, how to achieve this using the your elements. Harmonic motions, how to achieve it using the different types of actuators. As such, no harmonic drives, as per my knowledge.
Okay. To and fro motion, you are able to get the links using
Yes,
the
different, harmonic
normal conventional
motion.
electric
Yes,
motor.
yes, yes. How we'll achieve this using the stylus?
Oh, okay. Okay, sir. Thank you, sir.
Yeah, yeah.
Sir, any questions from other participants?
I think time is not sufficient for me. I think I'm feeling I'm not able to
Yes, sir.
deliver in time all. Correct. I took a lot of time in my lab visit. I'm thinking.
No, sir. It's a valuable decision, sir.
Yeah. Sorry.
Sir, as my personal opinion, sir,
Yeah.
I have experienced in all the dimensions, not exclusively on the technical. You enlightened us me latest research, how it is going on in the lab, how the society, how the survey is going on, the data, how to analyze the data for the suitable for the future,
Yeah.
and the same time with the latest technology you have shared, sir. And as my personal view, I learned many
Vamshi,
new things.
Vamshi, this course
Thank
we
you,
are
sir.
taking, we are offering in IIT Madras. We are taking
Yes,
52 classes, one semester, but difficult
Yes,
to
sir. Yes, sir.
make this in 1.5
Yes.
hour.
Yeah, sir. Yes, sir.
Yeah,
This session enlightened us and briefed us how the things are going on, which because we in the faculty department role, we are in
Yeah.
routine in the life. When we come out and go through these kind of sessions, surely enlightened us to think what next happening, what we have to
Yeah.
gain for enrich the for providing the students. This is a very
Right.
wonderful session for me personally, sir. Not as a
Thank you very
participant.
much.
I
But
personally experienced it, sir.
from my side, I'm thinking that I'm not able to finish all my slides.
Sir,
If you're giving
sir,
more
my
time,
personal thing, sir.
I think one more slot is required for me. Sorry for that. Later,
Yes, sir.
next time we'll do it. Okay, no need to worry.
Yeah, thank you, sir. Thank you very much, sir.
Okay, thank you very much.
Sir, any participants, sir? One more time, I would like to remind the participants to raise any
All are telling
queries.
lab is good, very informative, very good. Appa. Thank you very much to all,
Sir.
one and all. Okay,
Yeah,
we are
sir.
conducting these
Truly,
courses.
I will suggest my students to utilize the NPTEL course, sir.
Yeah,
Oil,
NPTEL.
hydraulics, and pneumatics. Sure, sir.
Yeah. Please, you'll
I
tell
will
them.
remind
And
them to
also,
utilize the opportunity.
okay. This type of courses, FDP, how you are doing, IIT Madras will also do these courses. I will
Yes, sir.
invite you people to our course,
Thank you, sir.
in
Thank you,
which
sir.
we are interacting more. From morning to evening, we are there. No, we'll discuss much about that. Okay.
Thank you, sir.
Sir,
Okay. Thank you very much.
that course is for faculty as well as the students, or only for students, sir?
Only for faculty, madam. The
Only
FDP
for-
courses like SCRB schools we are conducting only for the faculty. It is a free course. How we are doing? It is all our physical courses. We are inviting you to the IIT Madras. You stay in the Taramani guest house, and more than that, you are interacting physically with the teachers.
Oh, super,
Okay.
sir. When will be the course, sir? When will be the course, sir? I am in Chennai only. If we
Oh,
know,
very good.
we can attend that one.
Yeah, keep in touch with me, madam. Okay, you will get it, my email ID and everything in the portal. You keep
Okay.
in touch with me. I will call you to interact with us physically. Okay, no need to worry, madam. Okay, we are
Thank
doing this course, this type of courses many. Okay.
Okay, sir. Thank you, sir.
Okay. Also, you will bring your student to our IIT Madras to show our lab also.
Sure,
Whatever
sir.
you are seeing, please, this is a big opportunity to use because you are in Chennai. Please welcome to IIT Madras to interact with our student. You are still very happy. Okay.
Sure, sir.
Sir, are there any FDP courses also related to that, sir?
Yes, robotics. Last time we have conducted on the mechatronic system, micro machining, robotics. Many courses we have conducted, sir. Full continuous courses on kinematics and dynamics only, and sometimes sensors and actuators only. Like this, we have conducted many courses.
Okay.
To be conducting,
Can you find it on the website of IIT Madras, sir?
Yes, 100% you will get 100% on the teaching website. Now we will call it as a code, TODE code.
Sir, one clarification, sir.
Please,
Okay,
please,
sir.
Sir, one
Please.
clarification, sir.
please.
Sorry for interrupting. Sir,
Yeah, who is-
any limit is there for student count, sir, for getting you into IIT Madras from our college?
No, please tell me, Ashok, you tell me, student. What is your doubt?
Yes, sir. Sir, any student limitation count is there? For example, we can bring 30 or 60 students like that we are asking, sir.
No, any student, n number of student, you will bring it. IIT Madras is yours, not mine. But
Sure,
you have
sir.
to,
So then,
you have to fix to which lab you are going.
no,
For
sir.
example,
We
you
are
are
from
coming to,
I am from RMK group of institution.
okay. Now, if you are bring your student, you have to
I am
meet
from,
the fact.
I am
No, 1 minute, you
Hmm.
listen. 1 minute. You know, there are IIT Madras is, yours. Okay, you have to visit some labs, correct? You want to see my lab, you have to take permission from me, letter. Sir, we are visiting to your lab. Kindly will permit us, our 60 students, to interact with you during this time. Okay. In vacation and all, most welcome to visit
Okay.
some of the lab. You know, one more thing, research park also you may visit. Research park in IIT Madras is very tremendous way it is. Okay. You all are welcome to IITs. No need to worry. But you have
Sure.
to write, you need some contact. Okay. Okay.
Sure, sir. I will be in touch with you so that I can bring my students to you, sir.
100% most welcome. Okay. No need to worry.
Thank you, sir.
Okay. Okay. Any more doubts are there?
Thank you, sir.
Sir, with robotics, can we go for low cost automation? Is
Yeah,
that possible,
100%,
sir?
sir. We are developing the, last time one of my students developed the very low cost, 55,000 robot, which can be working like a epoch robot. Epoch robots are there where we are doing the transmitting the data, one robot to collaborative robot, multi-agent. He developed the one robot similar to that with the 25,000, which is used to communicate to multiple robots in the environment. Low cost.
That means human intervention is
Please,
not required anymore.
please, who is this? Rishikaran, correct? Sanket. Please,
Yeah, RS
yeah,
Kiran.
please
RS
come
Kiran.
to our lab. We'll show you the low-cost robots developed by our students, sir, which are very effectively working than the commercially available robots of 1.5 lakhs and all. Very simple. Only,
That's great, no? That India is also moving forward.
yeah, please. Okay.
Thank you, sir. Yes.
No need to worry. Email ID somshekhar@iitm.ac.in, madam. Somshekhar spelling is, I am typing here, Somshekhar, SOMSHEKHAR @iitm.ac.in. Somshekhar spelling, you'll see KHAR it is, okay?
So participants, any doubts?
We can send our request to this email ID. Is it okay, sir? To your email ID.
Yeah,
For the industrial visit
to
as
see
well.
my lab only. No,
Yeah, okay, sir.
Madam ji, to see my lab, IIT is, different wing it is, understood? If you want to visit our lab, this is my email ID, okay? I will show you, I will make you to interact with my scholar, okay?
Okay, sir. I am Shobna from Pratyusha Engineering College,
I'll
sir.
also-
I will contact you, sir, through this email ID.
Okay. Your Pratyusha Engineering College of Ramesh Babu, correct? Now Ramesh Babu, principal?
No, sir. Principal, sir. Now PLN Ramesh, sir, is our principal.
I
Ramesh
know him,
Babu,
Ramesh.
sir,
He's from CIT.
before 1 year.
Yeah, CIT, Chennai Institute of Engineering.
Yeah, sir. Yeah, sir.
I am very good friend of mine. Okay, I'll convey my regards to him. Okay, madam.
Okay, sir. Now he is in Sriram Engineering College, sir. Ramesh Babu,
Okay,
sir.
okay. Very good.
Okay. Thank you, sir. Thank you.
Bye.
Sir, can you stop, sir?
Yeah, I'll stop now. Okay. Good night to everyone. Okay. Bye.
Sir, 1 minute, sir. Omsi Krishna, sir. Sir, Dr. Omsi Krishna, sir.
Selva Kumar raised the hand. Any Selva Kumar? Any doubts are there, Selva? Selva Kumari, I think it is correct. Selva Kumari?
Yes, sir. Selva Kumari.
Oh, sorry. Madam, you raised the hand.
Hello.
Sir,
One question from my end, sir.
Yeah, please. Who is this? Dheeraj.
Sir, sir, Dheeraj Joshi, sir.
Yeah, please, Dheeraj.
Sir, how do you address that thermal management challenges in the high power robotic joint, sir?
What type of thermal management?
Actually, I am from the thermal domain.
Yeah. The robot, the thermal robots working in the, casting, working in the other many design aspects are there. We have to consider many things about thermal management means, when a robotic end effector interacting with the hot metal in the foundries, or in the casting, pouring. There are many design aspects we have to consider while designing the grippers.
Yes, sir.
Or similarly, what we are doing in our laboratory, we are subjecting these for the coupled problems in the CFD analysis before arriving the material selection and all. Okay, Dheeraj?
Okay, sir.
Vamsi sir.
Sir, thank you, sir. Thank you, Gurmesh, sir.
Yeah.
Sir, it's my wholehearted thanks to you, sir.
Thank
You
you
have
very
spent
much.
your valuable time with us, and in spite of your weather conditions in the Chennai, you have
Yeah,
arranged everything for us to exchange the latest information, technology, what is happening, and make us awareness about the robotics, everything, sir. So even in the time of 9 o'clock in the night, so you have spent your valuable time to share this faculty fraternity for a better enrichment and to present for the future. So through this FDP program, I would like to thank on behalf of our Sri Venkateswara College of Engineering, Tirupati, Andhra Pradesh, sir, Department of Mechanical Engineering. Thank you very much, sir.
Thank you
Your
very much.
valuable time was spared with us. Thank you, sir.
Thank you very much. But you are gathered many participants. I'm very happy. Okay.
Sir,
Best of luck.
thank you, sir.
Best of luck.
Thank you
Okay,
very much,
thank you.
sir.
Thank you so much.
Sir.
Bye bye.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you, dear participants. Can you leave?
Thank you.
Attendance link is shared in WhatsApp group and chat box, YouTube also. Can you fill your feedback link as soon as possible? We will close at 12 o'clock at midnight. We will close the attendance link. Go and please fill the form, sir.
Thank you. Bye.
Thank you.
Thank you, sir. Good night.
Good night. Good night to all the participants. Thank you for your support.
Good night, sir. Thank you, sir.
Good night, sir. Good night, sir. Thank you for all patience.